In this video, we're going to be looking at a paper called Runtime Monitoring and Resolution of Probabilistic Obstacles to System Goals. This paper aims to run a self-adaptive system and make goal-oriented decisions during runtime to best achieve the objective requirements of the system. So essentially what it's going to be doing is running a self-adaptive system alongside an application, and then watching that application, monitoring it, and making sure that it's meeting its goals throughout the lifetime of the system. Other research and other approaches to this typically tend to try and predict the problems that this application will come up against, the changing environment and conditions that the application will come against before it runs, while this one tries to do it during the runtime. So it's analyzing the conditions as well as the application. So the system itself, the whole overall system involves the application we're monitoring, a self-adaptive system to change it, and then a set of goals, high-level goals and leaf goals that it needs to satisfy to a certain degree. These goals can be expressed as Boolean logic goals, so that the computer can read them very nicely and go about satisfying them. And so the self-adaptive system just uses a classic monitor, analyze, plan, and execute progression within each cycle of its adaptiveness. So how does the self-adaptive process actually work? The process that they are presenting in this paper. Well, there's 6 steps. The first step is to create a monitor for all the leaf obstacles at the start of the program. And this monitors the conditions of the system and the potential obstacles that could come up about that. In the second step, whenever all of these leaf obstacles are monitored regularly, but whenever a new leaf obstacle comes up, say a new condition is the environment changes in some way, a new monitor is started for that. Finally, in the third step, each of these obstacles is propagated upwards through an obstacle and goal refinement trees to the high-level goals. This simply allows our application to see if we're still meeting those goals with the conditions that we're looking at. So in the fourth step, we are going to be seeing if the high-level goals still meeting our requirements, our system requirements, and if they are not, then the current countermeasures that we are using won't be appropriate, and we'll have to choose some new ones from a list of potential countermeasures. In step 5, we simply update the model with our new goals and obstacles in the way that the model is updated. And then finally, we need to change our software to use these new selected countermeasures that we have decided on. So how do they go about validating their system? Well, they chose an application, an ambulance dispatching system. Essentially, it's a system that dispatches ambulances to emergencies or calls throughout a city. During running the system, 24 hours results in different kind of conditions that the ambulances run into during the day. For example, you might have rush hour, you might have you might be at the start of a shift or the end of a shift, you might be at nighttime. There's all these different conditions that can change, and so the system changes the different countermeasures, selects different countermeasures depending on whether the goals, the response time, or the amount of time on the road, how well they're being met. They found that this application works very well, and they managed to maintain high-level goals very well by choosing appropriate countermeasures. And this occurred throughout the day, and so at every different kind of condition that they came across, they managed to adapt to it and adapt to other conditions from particular conditions. So in conclusion, by using a goal-oriented model, they could choose appropriate countermeasures to combat the changing conditions of the system. This goal-oriented model kind of filters up obstacles in the way, problems that the model has come across, and sees if it's satisfying the goals, and then chooses appropriate countermeasures to best fit those goals, satisfy those goals again. They mentioned that further research could be done into looking at the cost or weight of particular countermeasures, the countermeasures that are available for the system to use. They also said that more expertly studying these countermeasures per application would be a very useful way of being able to select the countermeasures more appropriately. They mentioned that machine learning could be very useful in this area of selecting them appropriately. Thank you for watching.